Next, we have a very simple question. It says a magnetic dipole of dipole moment M is placed in a non-uniform magnetic field. If the position vector of the dipole is r, then the torque acting on the dipole about the origin is, we have a bunch of options, and even so it's just a simple formula based question. You should be aware of this, that option C is the correct, because we have torque is given as M cross B. So you were given this additional extra information of the location of the dipole being R. That is fine. So that's like extra information. So they just gave it to you to try and confuse you. And then you have this bunch of options with R involved. So that was just there to confuse you. And you can even see that option A is dimensionally incorrect, because it is the dimensions. If you look at the dimensions of this would be a dimension of the distance times the dimension of the magnetic dipole times the dimension of the magnetic field. But we know that torque is M cross B. So dimensionally, if you try to find out the dimensions of this, you would have the extra dimension of R. So dimensionally also, this expression is incorrect. So sometimes when you are not able to solve the question, this was very simple, but sometimes when you are not able to solve the question properly, you can use this dimensional analysis to rule out the incorrect options. So for example, if I did not know the correct option, even then I could just rule out option number A, because I know that dimensionally these dimensions do not match up to the dimensions of torque. So sometimes dimensional analysis can prove to be a useful tool in trying to eliminate or reduce your number of options that you have, and then you can try and figure out which one would be the correct answer. So yeah, this was pretty much simple.